Today we're going to do the math practice in section 8.1, which concerns velocity and momentum. In problem number 1 on page 255 of our textbook, Science Spectrum, we will need to find the velocity in meters per second of a swimmer who swims exactly 110 meters toward the shore in 72 seconds. So the first thing we're going to do is go to the find, which is right here. And what do we need to find? We need to find a velocity in what? Meters per second. And who are we doing this for? We're going to do this for a swimmer. Now, after we do the find, what are we given to find this with? Well, we've given two numbers. We have 110 meters is what we're given, and 72 seconds. So what is 110 meters? 110 meters equals what? The distance. And then what is the 72 seconds? 72 seconds equals time. The equation we are going to work with is velocity is equal to, let's call this just V, is going to be equal to distance divided by time, and this we can state this simply as d over t, d divided by t. So let's go to our solution. The first thing we're going to do is plug in. So velocity is equal to our distance, which is 110 meters, divided by our time, which is 72 seconds, and that is going to give us 1.5 meters per second. And sometimes this is written out as 1.5 meters per second, or sometimes 1.5 meters per second this way. So all three of these answers would be considered correct. Next problem. I'm going straight to number 4 on page 255. This time we need to calculate a time in seconds for an Olympic skier who is going to be taking to the finish of 2.6 kilometer race at an average velocity of 28 meters per second downhill. Notice this does have a direction. So we just have a diagram up here, and here's a person that's coming along here, and he's on a couple skis coming downhill, and he's coming downhill, and it's at 28 meters per second. And notice it is downhill with a direction which gives it a velocity rather than a speed. So what is it we want to find? Find the time it's going to take in seconds. And do we have all information in seconds? I think we do. We have a seconds in the problem here, not hours, not minutes, but in seconds. So what are we given? We're given a distance equal to 2.6 kilometers. And what do we also have is we have a velocity equals 28 meters per second. So what do we have? We have a kilometer thing here, and then we have a meter thing here. Okay, so we're going to have to convert this time. So what's the easiest way to convert? Let's go with 2.6 kilometers, and let's convert that, multiply this by a conversion factor, and change kilometers into meters. And see how I set up this ratio? Meters over kilometers, so that kilometers can cancel. Okay, so for there is 1,000 meters for every 1 kilometer. Okay, this is a ratio of 1 right here. This value here is ratio of 1, a conversion factor. Now we can cancel the kilometers, and equals 2600 meters. So we've just changed the distance from kilometers into meters. Now the equation we're going to use is still pretty much the same. It's going to be velocity is equal to distance divided by time, but That's not what we're looking at. We're looking for time. So what's the first thing we need to do? Can we multiply both sides by time, cancel the t, and then can we divide both sides by v? Divide both sides times 1 over v, same thing, times 1 over v, both sides. Okay, and then the v's cancel, and what are we left with? We're left with an equation that is time is equal to d distance divided by v velocity. Okay, now we can go ahead and solve. So the time is equal to the distance, 2600 meters, divided by, and what do we have here for the velocity? The velocity is up here in 28 meters per second. 28 meters per second. And what is that equal to? Well, the meters cancel, and since this is the same as 1 over seconds, can be written off that way. Okay, so then the seconds comes up, so now we have 2600 divided by 28 and actual seconds. Since you're dividing by 1 over s, that's just s. And then now we can pull out our calculators, measure it out, and this is going to be more or less than 100. Should be a little bit less than 100. 93 seconds. 2 digits to start, and both are numbers, and so we only end up with 2 digits here in our answer. So it's 93 seconds. Not 92.5, not 95.6, not 93.257631, whatever it is on your calculator, just 2 digits, 93. Okay, so now we're going to go to the next problem, which is on page 257, number 1A, calculating momentums. So we're up here. So we have to know what our momentum is, and we have 75 kilograms as a speed, and this is actually a skater. I need to put a K in there. Skater moving forward at 16 meters per second. So what is it we need to find? Momentum. I'll just say MOM for mom, for momentum. And what are we given? We have a velocity that is equal to 16 meters for every 1 second. I'm just taking the translation up here of meters per second and translating it into a direct ratio, 16 meters per 1 second as a ratio. We also have a mass, which is equal to 75 kilograms. And what's the equation? We know that momentum is equal to mass times velocity. So our solution then is simply momentum is equal to a mass of 75 kilograms times a velocity of 16 meters per 1 second. We can go ahead and translate this and move it together, get all the numbers together. 75 times 16 over 1 times kilograms times meters over seconds. And notice I put all the numbers together in one spot, and I put all the units together in one spot, and then we figure out what we have. This is going to equal to 1,200 kilograms meters per second. And that's your answer for the momentum.